Now, in today's session, we will have what are the different types of sampling methods? What are the different methods through which we can do the sampling process? So basically, we have when we considered methods of sampling, there are basically two kinds of sampling. One is probability and the other one is non-probability sampling. Under these two categories, which is probability and non-probability, there are many different methods. And in today's, we'll go through that in one of the sessions. One of the methods we'll be doing in this session only. So if you see non-probability sampling, there is convenience sampling, there is quota sampling, there is judgmental sampling, and there is snowball sampling. In probability sampling, we have simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So what is non-probability sampling and probability sampling? So what is the basic difference in the two broad categories of sampling, which is probability and non-probability? As the name suggesting, the basic difference is the word probability, and it is a measure or of how likely an event can occur. Here we are very much interested in a unit of population which is coming into the sample, and hence we can say that in probability sampling, each member of the population has an equal chance of being selected. But in non-probability sampling, since elements are chosen arbitrary, there is no way to estimate the probability of any one single element that will be included in the sample. So basic difference between probability sampling is and non-probability sampling is the probability of selecting a single item from the population to the sample. So this is a basic difference between these two. Probability sampling. So if you see the units from the population which are randomly selected, and each unit's probability of inclusion can be calculated. So it will give reliable estimates, and that can also be produced along with the estimates of the sampling error. And through that, the inferences which we can make about the population. Okay, but it does not guarantee representativeness, but allows assessment of sampling error that I told you. And it also reduces the possibility of selection bias. This is very important point in probability sampling. Why we go for probability sampling? Because the one of the main and the primary concern for using probability sampling is to reduce the possibility of selection bias. Because in many of the studies or in many of the trials, basically you will see that majority of the researcher will try to choose those samples only, or those patients only which they think will not harm the intervention. So that is the reason why the selection bias has to be reduced. If you go through if you conduct any clinical trial where you have cases and controls, basically if you have the study design of case control study, so in which you have to take cases and in which you have to take controls also. So my point is, if you are a researcher, then and in the population you have someone that you know, so definitely you will never take that person to the cases. Always you will select that person to the control rather than the intervention group. So to reduce that selection bias, we go for probability sampling. This is the main reason to go for that. Probability sampling, as I told you, 4 types. There are basically 4 types: simple random sampling, systematic sampling, stratified sampling, cluster sampling. There is one more also, multi-stage sampling. And in simple random sampling also we have two kinds of sampling. One is simple random sampling with replacement, and the other one is simple random sampling without replacement. Simple random sampling. So this is the very easiest method of sampling, and it is the one of the most commonly used sampling method in today's scenario. Advantage of this technique are that it does not require any additional information on the frame, such as geographic areas or any other factor that can be included. And other than the complete list of members of the survey population, along with the information for contact. Also, simple random sampling is a simple method, and the theory behind it is well established. You see standard formulas that exist, which are to determine the sample size and the estimates and so on. And these formulas are also very easy to use also. So this is the primary reason why the most of the researchers in today's world, in today's era, they go for simple random sampling. The primary method is this only. If you see, the principle behind simple random sampling is that equal chance of drawing each unit. So now here I'll say, just now I have told you that in simple random sampling also there are two things. One is simple random sampling with replacement, and the other one is simple random sampling without replacement. Which means in simple random sampling with replacement, if you draw one sample from the population, then you will put that sample again in the population, and then again you will draw. In the similar manner, you will draw each sample from the population. Hence, the name is simple random sampling with replacement. In without replacement, you will not put back to the population. You will, once you draw that sample, it will be in the sample. From the rest of the remaining population, you have to draw the other sample. I'll give you one example of both the methods. First one is simple random sampling with replacement. So what does that mean? With replacement mean, let's suppose you have 10 balls in a basket, and you have to draw any 4 balls from that basket. So you select one of the balls from those 10 balls you have. When you have selected, then in with replacement method, you will again put that same ball in the basket, and again you will put the you will draw from that population, from those 10 balls. Without replacement scenario, when you draw the one ball from the basket, then it does not require that the same ball has to put again in the basket. From the remaining 9 balls, you have to draw the sample. So this method is simple random sampling without replacement. So again, there is one major difference between these two. And what do you think, which method is preferred over the other method? Which method is preferred? What do you think, guys? Is simple random sampling with replacement is better, or simple random sampling without replacement is better? Yes, Deepak.
Without replacement.
Pardon?
Without replacement.
Why?
Because it reduces the chances of the sample being repeated.
Yes, I mean you are correct, because what you are doing in with replacement, you are putting back the sample to the population. That means you are cutting the chance of the other units from the sample to draw, other units from the population to draw in the sample. That is the main reason we go for simple random sampling without replacement, because in that scenario you have equal chances of being drawing of each individual units from the population. That is why we go for simple random sampling without replacement. Although it is easy to apply simple random sampling, to small population, it can be expensive and unfeasible for the large population at times. Why? Because all the elements must be identified and they must be labeled also prior to sampling. So that is why it can also be expensive if personal interviewers are required, since the sample may be geographically spread out across the population. Okay, that is why the second point, units may be scattered. They may be scattered across the geographic area. So it is very difficult to draw the sample. Now see this example. Now let's suppose you have to evaluate or you have to estimate the prevalence of tooth decay among the 1200 children which are attending a school. So now you have complete list of children that are attending the school. This will be your sampling frame. Children numerated from 1 to 1200. They will be labeled from 1 to 1200. And you are given that the sample size will be 100 children you have to take in your sample. So now you will randomly sample children from those 1 to 1200 students that are labeled prior. How you will do the random sampling, that is being described in the further slides. How to randomly select. So you would have all the 1200 students mentioned in your dictionary or diary or sampling frame, whatever you may call, and from their names in given in the dictionary or diary, you can randomly pick any 100 number of students randomly. That is one method. Okay, let's suppose you have selected 20, then 33, then 40, then 45, 46, and so on. One method is this. You see, randomly selecting any number of students until we didn't get the 100 students. Or there is another method which is random number table. For example, you selected this number and you cross it. Why you are crossing it? This shows that the method that you are implying in simple random sampling is without replacement. Okay, so taking any random number from the table, let's suppose you have taken this 21100, which is marked in circle. So last three digit is 100. So let you take 100 and the dictionary, whatever be the person listed in 100th number, that will be your first sample. And similarly, you can take any number of sample from this random number table. So this is the way from which you can select the sample from the random number table. Understood? Till now, any query? Or I should go ahead?
Yeah, you can. So it, like, once the number is selected, it just progresses towards the other and it doesn't go back.
Again, if you are cutting that number, that means you are taking without replacement.
But how about the previous, like, 57172? So is there a chance of that number being selected again, or once that is over, like, it cannot be selected?
That is what I'm saying. If firstly you have to decide whether you have to go for with replacement method or without replacement method. If you have chosen that you will be going with simple random sampling without replacement, then one number cannot occur twice. And if you have chosen by going simple random sampling with replacement, then one number can occur twice in your sample also. Understood?
Okay.
Yes. So moving ahead is the systematic sampling. The first one we have covered, simple random sampling. Now the next one is systematic sampling. So it is also called as interval sampling. What do you mean by systematic sampling? It means that there is a gap or interval between each selected unit in the sample. Systematic sampling, by name itself, you can see there is a structure, there is a system in selecting your sample from the population. So systematically spreads sample through a list of population members. In nearly all practical examples, the procedure results in a sample equivalent to simple random sampling. Now, this is important slide. So in order to select a systematic sampling, you need to follow some steps, like number the units on your frame from 1 to n, where n is the total population size, whatever will be your population size. And now firstly, you have to determine the sampling interval, which is k, by dividing the number of units in the population by the desired sample size. For example, in this scenario, if you to select a sample of 60 from a population of 1200, you would need a sampling interval of 1200 divided by 60, which is 20. Therefore, the k value is 20. So you will need to select one unit out of every 20 units to end up with a total of 60 units in your sample from 1200 population. Understood? So what is system here? What is gap here? The gap is of 20 units. So after every 20th unit, you have to take your sample from the population. And that is why you will complete the 60 sample size from 1200. 60 into 20 is 1200. So select a number between 1 and k at random, and here k is 20. So select a number between 1 and 20, any number, and this number that you will be selecting is called as the random start number, and it would be the first element or the first number which will be included in your sample. Okay, so using the sample above, you would select a number which is between 1 and 20 from a random number table. If you choose, let's suppose if you choose 8, that means the 8th unit on your frame would be the first unit which will be included in your sample. If you choose 2, then your sample would start with the second unit on your frame, and so on. So select every kth. In this case, you will be 8 or 2, whatever the number you have selected. After that first number, for example, the sample might consist of the following units to make up a sample of 100. Understood or not?
So randomly selected is a starting point. The first point is randomly selected.
So you have population size, you have sample number, that this much you have to take for the sample, and firstly you have to determine the sampling interval.
Okay.
Yes. So firstly you have to identify the sampling interval, which is dividing the total population size by the sample size. Once you get your sampling interval, so this means that after every this number you have to take your sample, you have to draw the sample. But the random start number, you can choose any randomly between first to the kth number, which is 20 in this scenario. For example, if you choose eighth. So the first person or the first unit in your sample will be the eighth on the sampling frame, on the sampling list. And after that, after every 20th unit, you have to select your sample. So first will be your eighth, which is randomly selected between 1 and 20. Second will be 28. Third will be 38. Third will be 48. Fourth will be 68. Then 88, 108, and so on. Understood?
Yes.
So this is a systematic sampling. So if you have this, if we consider the same sampling frame, so the first number that you select is 8th, then 28, then 48, and then vice versa, and then similarly you have to go ahead in the same manner. And this also, let's suppose you have 55 or so on number. First you have fourth number, and after every 10th element you have to select, and fourth is your first number, then 14, then 24, 34, etc. So in this manner you have to go in the systematic sampling. Same, this is the example that I want to show you. This is a particular scenario. So the biggest drawback of the systematic anyone can, this is the open stage for each student, that what is the biggest disadvantage of this method? Biggest disadvantage of systematic sampling. Whatever, I mean, you can contribute, you can say anything that you have right now in your mind, that what is the main drawback of this systematic sampling?
Do we lose choosing the samples at the extreme end? I mean, like once we sample size is arrived, like once the sample size is arrived, we tend to choose the selecting samples from the extreme end. I mean, if the sample size is arrived at probably for 600 cases, and from the 600 to 1200, we don't get a sample population. I mean, like we don't get any samples, and
probably you are correct, but the biggest drawback of this is that, let's suppose if there is some cycle in the way the population is arranged on a list, and in that cycle that coincides in some way with the sampling interval, which means the possible sample that may not be the representative of the population. For example, let's suppose you run a large grocery store and you have a list of employees in each section, and the grocery store is divided into the following 8 sections, which is bakery, pharmacy, and dry cleaning. And each section has 10 employees, including their manager also. So making those 30 employees in total. So your list is ordered by section, with the manager listing in your first, and then all the employees, which is obviously by the descending order of the seniority. So if you want to survey your employees about their thoughts on their work environment, so you might choose a small sample to answer your questions. And if you use a systematic sampling approach and your sampling interval is 10, the kth value is 10, then you could end up selecting only managers only. You will not be able to capture the employees. So this type of sample would not give you a complete or appropriate picture of your employees' thought or the research question that you have in your mind. So in this manner, this is the major drawback of the systematic sampling. That is why in most of the cases, people try to avoid systematic sampling, but wherever required, so they use. I hope you understand the drawback of the systematic sampling. So stratified sampling is sampling in which we divide the population into homogeneous groups, and those groups are called as strata. And then in each independent samples are selected from each stratum. Okay, so you have population, then you divide those population into homogeneous stratas or homogeneous groups, and each single strata, each single group is called as stratum. So population dividing into homogeneous stratas, and then you select individual unit or individual samples from each stratum, from each groups, and any of the sampling methods mentioned in specifically in this PPT can be used to sample within each stratum. The sampling method that vary from one stratum to another. Obviously, if you have one stratum, if you have, let's suppose you have three stratum, three groups you have. So in each group, the sampling method that could vary. Let's suppose in first group you have selected samples with simple random sampling without replacement. In second group, you select the sample with simple random sampling with replacement, and similarly for third one also by any other method. Okay, so the sampling method varies in individual stratum. When simple random sampling is used to select the sample within each stratum, the sample design is called as stratified simple random sampling. Like I told you, in the first group, if you are selecting your samples from the simple random sampling method, then the method is considered to be as stratified simple random sampling. If you are going with any other method, then it would be considered as that with that name. Okay. So a population can be stratified by any variable that is available for all units on the sampling frame prior to sampling. For example, age, sex, residence, income status, etc. Understood the last line what I said? I said,
No,
pardon?
yeah, please repeat.
Yes, I'm repeating. I said a population can be stratified by any variable that is available for all units on the sampling frame prior to sampling, which means if you have population, if you have collected your data on some variables, for example, age, sex, residence, or any other variable. So you have to decide prior to sampling through which variables you have to make strata for those population. When you will sample, then you will not at that exact point you will not say like I'll make groups with age or I'll make group with gender. No, before sampling only you have to make sure by which variable you will be making your groups, and then you have to make those data, and then you have to sample your sample from the population. Stratified sampling also ensures an adequate sample size for subgroups in the population of interest. When a population is stratified, then each stratum that becomes an independent population, and you will need to decide the sample size for each stratum, which means when you are dividing your population into groups, then each individual group or stratum that will become your independent population. And for independent population, you have to define the sample size for each stratum. For each group, you have to decide your sample size. Understood? This process, is called as stratification. So there are several new terms that you have learned today. One is strata, the other is stratum, and the third one is stratification. Strata are groups that you divide your population. A stratum is the individual or the single group, you call those as stratum, and this whole process is called as stratification. Understood? Just give a quick thumbs up. I can move ahead.
Pratik, is there any specific rule by which we are supposed to give sample size for every stratum that we are supposed to do for the population?
No, there is not any specific rule, but like for the calculation of sample size for the whole overall population, similarly you have to calculate the sample size for individual stratum. You cannot make a different estimation of the sample size for each individual stratum and for the overall population. So there must be the same methodology for the calculation or the estimation of sample size for overall sampling also and for individual stratum also. Understood, Felicity?
You said sample size for each stratum is defined, right? Can you explain it a little more?
See, the question that you raised for the sample size, that I will cover in the estimation of sample size part. In that part, I will cover these all the scenarios.
Okay.
Okay. For as of now, you just understand that for overall sampling also and for individual stratum also, you have to follow the same process of the estimation of sample size. Okay.
Okay.
Yes. Mohan, do you have any question?
Can I tell, like, is there any example, real-time example? For suppose, if you want to conduct the survey about the people's performance for smartphones.
I'll give you one example. If you want to do a survey, and where you will be collecting your data in terms of age also, age of the participant,
Yeah.
gender of the participant, their income status, their residence, whether they live in urban or rural areas, any other variable, if you collect the data, then before sampling only, you have to make the decision for which variable you have to make the stratum. For example, if you have decided that we will make stratas for age category.
Age category, okay.
So you will be having some different age. For example, you will be having
24.
Age category between 18 to 24, 25 to 30, 31 to 40, 41. So you will make those number of strata. So one strata will be 18 to 24 year age group people. The other one will be for 25 to 30 and similarly so on. So by that you have your individual stratum. Let's suppose you say for age, Deepak says for gender, then your stratum will become male and female.
Yes.
And some other says by income status and similarly so on. So by this way you can make your stratum for the population. Understood?
Okay.
Yeah.
So yeah, Pratik, if it is
Yes.
for like a status like based on gender, so there'll be only two stratum, right? Or only two groups.
Yes.
So then like again from that I should do a simple random sampling.
Yeah. That I already told you, na. You can
Okay.
sample from each stratum according to any mentioned sampling method.
Even
Be it a
systemic
simple
can be
random
used.
sampling or any other method.
Okay.
Okay, understood?
Okay. Yeah.
Yeah, okay, perfect. So there will be population which is divided into 2 or more groups according to some common characteristics, which in this scenario will be the age or gender or any other thing. And then you can take simple random sample selected from each stratum or each group. So this is the idea behind the efficiency gain obtained with stratification. Okay, if you create strata within which units share similar characteristics, for example, income or any other characteristics, and they are considerably different from units in other strata, for example, occupation or any other type of characteristics, then you would only need a small sample from each stratum to get a precise estimate of total income for that stratum. Okay, and then you combine those estimates to get a precise estimate of the total income for the whole population. So if you were to use a simple random sampling approach in the whole population without stratification, the sample would need to be larger than the total of all the stratum samples to get an estimate of the total income with the same level of precision. That is why the stratification process comes under the umbrella, because if you're not doing with the stratification, so you will require a large number of sample size to get the precise total income or any other characteristic. But if you are doing the stratification process, then with the smaller number of sample size, you can get the equal or the probably the higher level of precision also. Okay, understood? So this is the reason why the stratification comes. So one question that always comes in mind, why to do the strata? Why do we even require to create a strata? Why we cannot do with simple random sampling or without strata? So there could be many reasons to do so. The main one being that it can make the sampling strategy more efficient. So it was mentioned earlier also that you need a larger sample to get a more accurate estimation of a characteristic that varies greatly from one unit to the other than for a characteristic that does not. Okay. But by doing the stratification process, you can get the same level of precision with the smaller number of homogeneous subgroups. That is why the stratification comes. For example, I'll give you example also. But before that, let's see what the PPT says. This slide says is group comparison is the purpose of the study. If you want to further study within the group, or if you want your manuscript to be more specifically for any group or any other thing, then you can use stratification. Otherwise, you can simply get your estimate from the usual sampling, but to get any specific characteristics, you can go for stratified sampling for any group comparison. Some elements are more important in determining outcome of a research interest than are others, and all subgroups representing allowing separate conclusions about each of them. For example, I'll tell you, if every person in the population had the same salary, then a sample of one individual would be enough to get a precise estimate of the average salary. So in this method, in this way, the advantages of stratified sampling is more or less more compared to any other sampling process. With this, I'll conclude for today's session, and for tomorrow's session, we'll continue ahead with the stratified and more other sampling methods, which is cluster design or any other method.